Okay, this video is going to walk us through some just knowledge you need to know about LeChat's principle when you come into lab on or this next week. So first off, all I can say is take a minute and read this first page. You should have already watched the LeChat's principle video, that 10-minute long video I posted on Blackboard. This also is just, I think it words everything very well. It's a great walkthrough about what you're about to do. So please take a minute, just read these points. What happens to equilibrium? We know LeChat's principle is all about predicting how the reaction shifts, okay? When you make a change, when you add a reactant or a product, how does it shift? Does it shift left or right? When you, vice versa, remove a reactant or product. I don't even think I've talked about this in lecture, so please make sure to read this portion. How does equilibrium shift? That's the whole goal of lab today. You're going to have two equilibrium setups, which are going to be two reversible reactions, and you're going to make changes. You're going to add things, you're going to heat things up, cool things down, and see how equilibrium shifts. Okay, so read over this first page. I'm gonna focus on this part for just a second. Here's what you're gonna do. We're gonna examine, today we're shortening it, so two different solutions at equilibrium. In each case, you will make changes to the conditions, and then you'll make an observation. And that's what you're going to put in the data sheet. I'll walk you through what you should write down. And then you're going to determine from your observations how equilibrium shifted. And then at the end, you will make, at your post-lab questions, sorry about that. You'll be deciding how, what kind of reaction it is. Is it exothermic? Is it endothermic? Based on the observations you made, okay? So the next thing that's very, very important here is safety. We have several chemicals we're working with today that are dangerous chemicals, okay? First off, sodium or solid cobalt chloride. It is toxic and yes, indeed, it is a cancer suspect, okay? Being around it is not going to harm you, but if you drink it or pour it on yourself, that is terrible. So please be careful with this. If you spill it on your hands or anything, just go wash them off immediately. You will be wearing gloves, so be careful with this. Ethanol is also highly toxic and flammable. We'll be working with some ethanol today. Look at this. We will be working with concentrated 12 molar hydrochloric acid. Okay, it's extremely corrosive. I believe that this will be in the hood for you guys. So when it comes time to get that, you will need to go to the hood, I believe. If that's incorrect, I will tell you the day of lab. It might be at your station, but it should be in the hood because we don't want to be breathing this in. Acetic acid is an irritant, okay? That's it for equilibrium system 2. We'll have acetic acid. Be careful with that. And then methyl orange, which is what we will add to our equilibrium system to see color changes for number 2, is also toxic. So be careful with that. Now, the ammonium chloride, we're not doing that as part of system 3. We're not doing that. So we don't have to worry about that one. Additionally, we will be working with a hot plate, so just be aware of where the hot surface is. Don't accidentally touch it. Be careful with that. This portion right here, the hot and the cold water bath, will already be prepared for you. Or at least we will have ice available. So when the time comes, you may have to go scoop up some ice in a little beaker and make your ice bath. But the hot plates will be set out in lab. They'll be turned on. The water in the beaker, the hot baths will already be hot and ready for you. I don't know if we have enough hot plates for everybody to have their own. So there may be like a little community station between two groups where you go put your test tube there to heat it up. But I'll let you know the day of lab how that will be set up. But this part will already be taken care of for you. All right, equilibrium system 1 and 2. This is what I'm going to focus on. I'm going to talk us through these things really quick. The first one is with cobalt chloride, CoCl2, and water. Now, I have these written over here as well. So we will come to this note and I'll walk you through a few changes. But you'll see on the PDF, it tells you to start out with putting, step number 1 is that you will add CoCl2 to your test tube. That is essentially the same species as this CoCl4 2-, okay? I could explain the differences, but essentially these are the same. You're starting out with your reactants, okay? So it should be blue starting out. And if you look at your data sheet, this is where you're going to make your first observation. So I'm going to come down here. Here's equilibrium system 1. we are just going to make an observation about the initial color of the COCl2 and ethanol, okay? So you're just going to write what color it is. And it's going to say what species was initially present. People get confused with this word. All it means is what reactant or what product, okay? These things right here, water, this cobalt, hydrated cobalt species, chlorine, these are all the different species. So it's just asking you to write down what reactant or what product was initially present, okay? So you'll write your colors and you'll write what was initially present. Then, let's go back up. What's the next step? Then you're going to add water. Okay, so think about what's going to happen here. You're going to add water until you see a color change. So 2, if we are adding water, what are we doing? What are we changing? Here we are changing the concentration of a reactant. Water is a reactant. So we are going to increase the concentration of H2O. How will equilibrium shift? According to Le Chatelier's principle. And then what color change should you see? Now when you go to your data sheet, okay, after you add water and make your observation, come down here and you're going to write what change occurred, okay? You'll write the color change. So if it turned blue, you'll write turned blue. Okay, if it turned pink, you'll write turned pink. How did water affect the equilibrium? Over here on this side, you can see that's going to be the question for most of this conclusions column is which way did equilibrium shift? All right. So you're either going to write it shifted right, so you would write shift right, or shift left based on whatever happened. Okay. So you can say it shifts right or it shifts left. And that's essentially all you're going to write for this conclusion column, unless you're writing what species was initially present. So those are the kinds of statements I want you to make on your data sheet. Very short, don't write me sentences or paragraphs. And then what's the next step? Go back up here. Now you're going to add 12 molar HCl. Drop-wise, drop by drop. You're not going to squeeze a bunch in there, just drop by drop, and you'll swirl. It says stirring. You really don't have anything to stir. You just swirl it until you see a color change. Then you record your observation. After you've done that, okay? After you've done that, and when you're adding HCl, by the way, so this also confuses people. So step 3 was add HCl. What is HCl? This is an ionic compound here. What does it do in solution? It breaks apart into H plus and Cl minus when it's in solution. So what you're really adding, what's going to affect our system here is those Cl minus ions because they are a product. So when we're adding HCl, we are going to increase the concentration of Cl minus ions in the solution. What is that going to do to equilibrium? How will it cause it to shift? Okay, that's the thought process here. All right, step 4, once you've done those first 2 changes, now you're going to get it purple, okay? So whatever you need to add, if you need to add water to make it more pink, or if you need to add HCl to get it more blue, you're going to try to get it perfectly purple. That's right in the middle. And then you're going to pour half the solution into a dry test tube, and you're going to use that one as a control. So you're going to get it purple, then you're going to split it up into 2 test tubes, keep one on your test tube rack as a control, take the other one, place it in a hot water bath, all right, then record your observations. The last step is the ice water bath, okay? Once you've done the hot water bath, now you're going to go put it in the cold water bath. You should have a good amount of ice and some water. You want it to be really cold, that cold water bath. Then you're going to make your final observation. And that's it for number 1, okay? I will tell you how to discard these on the day of lab, okay? Second equilibrium system, we have acetic acid. So this right here, let's go down to number 2. This is acetic acid. And this is our acetate anion. And these are actually colorless. And because we want to visualize a change here, this is an acid system that is colorless, so we have to add methyl orange. This is an indicator that changes colors based on pH. Okay, This species right here, the hydronium ion, this is one of your polyatomics that you had to memorize. This lowers pH. The more H3O that we have in solution lowers pH. It becomes more acidic, the solution does, when you have a lot of H3O. And methyl orange turns red when there is an acidic pH, okay? So when you have a lot of H3O plus, when you have a lot of that species, your solution will be red. And if your equilibrium shifts the other way and you have very little H3O plus or a lower amount, your solution will become yellow, okay? So that's how this one's going to work. If you forget to add the methyl orange, you will not see color changes. Another note about that, though, as you're getting ready to do this, so here's where this whole paragraph tells you about this system. Where am I trying to find? It says you add it to the mixture. And, oh, I think we actually need to read step number 1. That's what I'm trying to... No, I think it's step number 2. Well, the first thing you're going to do is you're going to place your acetic acid in your test tube. Oh, here it is. Very small drop. This is what I wanted to point out. You're going to add one very small drop of methyl orange, all right? Don't do too much. If you do too much, then you won't see as... your color changes will be hard to see, all right? And on step 2, once you get the methyl orange added and you record the color, so if we actually, before we read step 2, come down here. You're just writing, what was the initial color of your solution, okay? Therefore, what species were the reactants or the products initially present based on the color, okay? Remember, the left side is yellow, the right side is orange, okay? And your color changes might not be like to bright yellow and to bright orange. They might be more like soft yellow to pink, okay? But you get the picture. If it's turning towards the red color, then equilibrium is shifting to the right. If it is turning towards the yellow color, equilibrium is shifting to the left. And then same idea with the blue and pink, okay? If it turns blue, equilibrium is shifting to the left. If it turns pink, equilibrium is shifting towards the products or to the right, okay? So once you record that initial color, now you're going to add a tiny amount of sodium acetate, all right? Sodium acetate. What is that going to do? Sodium acetate is also an ionic compound, Na. So in solution, it's going to break up, see, acetate C2H3O2. In solution, it's going to break up into Na plus and C2H3O2. So what you're really adding are acetate ions, and that is a product. So what we're doing when we do this is we're increasing the concentration of this acetate anion. What is that going to do to equilibrium? That's what you need to be thinking. And you should see a color change. All right, step 3 is you're going to mix in one of the test tubes, dissolve a tiny amount, just yellow if you're not careful. It says mix the materials from the 2 test tubes until you get a solution that is orange. So I believe here you're doing step 1 in one test tube, okay? Actually, I'm the one who's not reading. Let's go back and read step number 1 because this is going to help you out here. Place 1 ml of this and 1 drop of the methyl orange in 2 small test tubes. There it is. You're going to do this twice. Do it twice. So you have 2 small test tubes that'll look identical. Then in one of the test tubes, you're going to dissolve a tiny amount of the sodium acetate, okay, until you get it yellow. Now, step 3, now this one makes sense. You'll take some of the initial orange test tube, that first one should be orange or yellow, and then you're going to take some of the material from test tube number 2, and you're going to mix those until you get a solution that is orange, okay? All right, then you're going to do the hot water bath step and the cold water bath, okay? So if I will just read everything clearly, and as you're doing the lab, just read all the instructions first, follow the step to a T. I'll be there. You can ask me questions. Once you finish that, you're done, okay? So you just need to make sure that you have these first 2 tables here completely filled out, okay, before you leave the lab, okay? We're not doing this table. But then you're going to get down here to the post-lab questions. I encourage you, if we have time, I'm going to say we're probably not going to have time to sit and do the post-lab questions in lab. So you will be doing these on your own. But if you get done early and you happen to have some time before that first hour or the second hour is up and you start working on your post-lab questions, You need to finish these as well. You'll do it for equilibrium system 1 and 2. You will not answer any post-lab questions for equilibrium system 3. But the whole end goal of this is to determine, is this an exothermic or endothermic reaction? Number 1 and equilibrium system 1, and look down here. Is it endothermic or exothermic for number 2? That's the whole goal. I want to point out something on equilibrium system 2. People get really confused by these questions right here. And this first one, it says write an equation for the dissolution, the dissolving of sodium acetate into sodium and acetate ions. Let's do that together right now. We have, all that is it's actually what I wrote over here on this. Here it is as a compound, and it's a solid. And here it is as ions, and they're aqueous. Okay, so that is actually what you need to write there. That is the dissolving of sodium acetate into its ions, okay? Now, you're going to write which of these two ions actually affects the position of equilibrium. Which of those ions did I say was important? Which one can shift equilibrium, okay? And then which one is simply a spectator ion? The opposite ion, the one that is not in the reaction and that has no potential to shift your equilibrium. We call that a spectator ion, okay? So it's either going to be sodium or acetate for parts A and B. Which one will affect equilibrium and which one does not. I think that's it for this lab. I know I kind of rushed through this, but I did not want this to be a 20-minute video. I just wanted to give you an idea of what you're coming in to do, how to do it, what things will already be set up for you. And because when you come in, I might talk for 1 second and then I'm going to say, okay, go. And I expect you to kind of have your head on and know what to do. You should have all the reagents except for maybe the HCl at your station. All of them should be labeled and you should be able to find them and begin. You'll have your test tubes and all that will be there for you as well. So